All right, let's take a look at sketching tangent of a, I totally put this up here wrong, but sketching tangent, a shifted function of tangent. So let's do that. So let's look at some features of the graph. So we have the features of y equals a, excuse me, I'm sorry about that. We're looking at the features of the graph. So we have y equals a tangent bx minus c plus d. So this is the standard form of our graph. So we know that it's stretching by the absolute value of a. The period is going to be in the form of pi over the absolute value of b. The domain is where x is not equal to c over b plus pi over absolute value of b times k, where k is an integer. The range is always going to be from negative infinity to positive infinity. Because if you remember the way the graph of a tangent function looks, it goes on, up and down in both directions. The vertical asymptotes occur at x equal to c over b plus pi over 2b times k, where k is an odd integer. There is no amplitude. And y equals a tangent bx minus c plus d is an odd function because it's the quotient of an odd and even, that was missing, sorry, odd and even function of sine and cosine respectively. All right, so here is some list of rules that we can use to graph our one period of our. We can express the function given in the form. We have to make sure that it's in this form. We can identify the stretching or the compression factor, which is just our a. Identify b and determine the period. Identify c and determine the phase shift. Draw the graph of equals a tangent bx shifted to the right by c over b. So c over b is telling me how far I'm moving over to the left and right. And d is telling me how much I'm going up by. Sketch the vertical asymptotes that occur at x equals c over b plus pi over 2 absolute value b k, where k is not integer. Now also remember that I am only going to sketch today one period. The reason why we have this formula is because it continues on and on, right? And then we can plot any 3 reference points and draw the graph using those points. So I have my graph here, but I know that I don't have enough room to write here, so I'm going to go over to my next clear page and write there. So it's already in the form that we want it to be in. All right, so I can easily see what my a value is, b, c, and d values are. So my a is absolute value of 2. Absolute value is always going to be positive, so my a is 2. So that is my stretching of 2. The period, so I'm going to use b. So b is equal to pi. And so we know period is equal to pi over the absolute value of b. And so I get pi over pi, which is 1. My phase shift, we're using c, and so we have c, which is negative pi. Right? Because the formula has, and we can go back to that formula, it's minus c. And then ours has a plus c. So that means that it's negative. So it's a negative value. We're using the opposite sign. And so our phase shift would be c over b. So c over b is negative pi over pi, which is negative 1. And from that, we can find our asymptotes. We know that originally we can find them by doing the period divided by 2, and this is going to be plus or minus, so there's going to be 2 of them. And our period this time was 1. So it's 1 over 2. However, we have shifted. So asymptotes are on the x, so we need to look at the shift for the x. And so the shift for the x is referring to our phase shift, which was -1. So we need to add -1 to both our positive and our negative. So we know x equals 1/2, that's the positive, minus 1. And that's going to give me a -1/2. And then x to -1/2 minus 1. And that is going to give me -3 over 2. And I'm already running out of space, so I might go to a new page. What else do I need? So I have asymptotes. I know that this is where my asymptotes will be at. I also need my points. So originally we know that we use the origin of 0, 0, but our graph is shifted over to -1, and it's also shifted up -1. So our real point that we're going to use is -1, -1. So it phase shift over -1 and it went up, or actually went down, excuse me, for this D value of -1. So there's one of my points. The other point that I'm going to use, recall from our other formula that we used, we're going to divide P by 4. So up here again was 1. And remember, this is plus or minus. Let me put plus or minus. So I have 1/4. And again, I had to move this over and up. Move this over. So phase shift, I'm going to add that -1/2 to this. So this is going to be plus 1/4. So 1/4. Plus -1, or just -1, whichever way you want to think about it. It's -3/4. And I'm going to have to go to a new page because it's becoming too much on here. Just give me one moment. All right, sorry about that. So we know that one of the points that we're going to use is -1, 1 because of our phase shift of -1 and our shifted down of -1. So that's how we got that value there. Our asymptotes are at x equals -1/2 and x equals -3/2. We know that our phase, we're going to find 2 other points. So we're going to use P over 4. So that's -1/4. But we also have to make sure we use that phase shift of that 1/2. Of this -1 as well. So we're going to do -1/4. And this is plus or minus, minus 1. And then we have -1/4 plus 1. And so for the first value, we get -5 over 4. And for the second one, we get 3 over 4 negative. And actually this is positive and this is negative. So that's -3/4. So the -1/4 minus 1/2 minus or plus 1, -1, whichever way you like to look at it, and then positive 1/4 plus -1. And these are the values that we get. Now we have to take these values and plug it into our original equation to find our y. So these are x values. So we'll say y is equal to 2 tangent of negative, we'll use this one first, 5 over 4 pi, just plugging it in to our equation, plus pi minus 1. So I get 2 tangent of negative pi over 4 when I add those together. So this becomes 4 over 4, 4 over 4 minus, that gives me a negative 1, so negative 1, negative pi over 4 minus 1. And then tangent of negative pi over 4 is negative 1, so negative 1 times 2 is negative 2. So I get y is equal to negative 2 minus 1, which is equal to negative 3. So another point that I can use to graph would be at negative 5 over 4, comma, negative 3. All right, let's find the other one. We'll plug in negative 3/4. So I have y, and I'm going to give myself some more space. So I have y is equal to 2 tangent of negative 3/4 pi plus pi minus 1. And 3/4 pi plus pi, that's, you can turn this into 4 over 4. So 4 over 4 pi minus 3 over 4 pi gives me 1/4 pi. So I get y is equal to 2 tangent pi over 4 minus 1. Pi over 4, tangent of pi over 4 is 1. So I get, let me just put an equal sign here. 1 times 2 is 2, so I get 2 minus 1. 2 minus 1 is 1. So my third point that I get to plot would be negative 3/4, comma, 1. So now let's graph all these points. All right, so here's our graph. I went ahead and put our important points that we need to put on here. So first I have my asymptotes, and asymptotes aren't, as we've stated before, they're not actually part of the graph. They are just invisible lines that we use to kind of help build a barrier. Now, this graph is a little smushed, and I probably should have used a different graph, but we're going to try to make do with what we have. So at 1/2, we'll say this is right here. So I'm just going to draw some dotted line at x equal to 1/2. All right, and negative 3 over 1/2, 3 over 2, we'll just draw a dotted line there too. Really close together, so this graph is kind of, and actually no, I'm going to make this bigger. Okay, I'm sorry about that. I drew out a different graph, a new graph, and I just had to make it a little bit wider so we can see it a little bit better. I'm going to start off with my asymptotes again at negative 1/2 and negative 3/2. So negative 1/2 is right here. So it's my x equals negative 1/2, and x equals negative 3/2 is right here. So those are my asymptotes. So my graph should be in between those two invisible lines that we really don't have. And then I'm going to plot my point. So the first one is at negative 1, 1. So that point is right here. Then we have negative 5/4. And negative 3. So negative 5/4 we'll say is about right here. Oh, you can't see mine. We'll say it's about right here. And then negative 3 is right here. So we'll point one part right here. Negative 3/4 and 1. So that is right. We'll say that negative 3/4 is right here. And 1 is right here. And so we have something that looks like that. I know. My drawing isn't perfect, but hopefully this helps.